Hi everybody, I'm here to do a TC test, and this TC test I'll be following an individual's plan, and hopefully the plan will give me a solution for the problem. And this particular plan, the goal was to create two exponential functions so that their y-intercepts are no more than 10 units apart, but intersect at a point whose x-coordinate is very large. Moving on to step 1, the individual states that we have to choose two values that are 10 or less units apart from each other. This will be our y-intercepts, and they may be any real numbers and will be substituted in the b term in the equation they have provided. Before we move on, I'd like to let the individual know that the b value will not always be the y-intercept. In some cases where we have a horizontal vertical translation or horizontal structure compression, the b value may be far different from what the y-intercept actually is. Otherwise, they should also take note that they've forgotten a coefficient in front of x, which would have been the horizontal structure compression. And one could easily assume that there is no horizontal structure compression involved in this plan at all. Otherwise, that's something you should look into. Moving on for plan, I've chosen two values, a y-intercept of 4 and 10. 10 minus 4 is equal to 6. My intercepts are 6 units apart, which meets the criteria of the plan. I've now substituted these values into the b value of the equation, like the individual has told me to do so. And that's my equation so far. Moving to step 2. For the base, the values must have the same sign in front or be traveling the same direction. In other words, if you choose a negative y-intercept for one function, then the other function's y-intercept must also be negative. The same rule applies to the positive values. In this case, I'll choose to have both a positive base and positive y-intercept for both of my equations. But before moving on, I'd like to let the individual know that this step could be reworded a little bit better. However, it's alright. Moving on to step 3. Next, the base or a value must be a value less than 1 but greater than 0, because the x-coordinate of the point of intersection must be large. Therefore, it must be positive and not reflected over the y-axis. Write this as a rational number less than 1. Before we move on, I'd like to let the individual know the base of the exponent being a negative would actually be a reflection in the x-axis, not the y-axis, just to clarify some stuff. And yeah, moving on with the plan. I have chosen to choose two different bases for my functions. This is because the individual did not tell me to choose similar bases or different bases, so I have just assumed that we needed two different bases, which is what I've done. The first base is 0.5 and the second base is 0.75, all written as a rational number. And also, they should note that in the very last sentence, they write this as a rational number less than 1, and it must be greater than 0, like they have wrote in the first sentence. So that's something they should also look into. Moving on to step 4. For the horizontal stretch factor h for both functions, make sure the number is greater than 1. The larger the horizontal stretch factor, the better, as this creates a longer stretch function and allows for a large x value of the point of intersection. So, just to clarify a few things, I believe the individual meant that the h value in their base equation they provided was actually supposed to be a coefficient for x. In other words, the equation they gave us was the h value was actually a horizontal shift. And then the second equation, which has been edited by me, was h at x, and that's actually a horizontal stretch or compression factor. So as you can see in the two equations above, I've chose a horizontal stretch of 100 and 120. The individual did not say I needed the same one or different ones, so I assumed that I needed different stretches, which I have done so. And that is how it will look like in the equation. Moving on to step 5. The k-value or asymptote must be either negative or positive for both functions. Whatever sign is chosen must be used for both equations. They may be any real number. So I've chosen to go with positive 4 and positive 10. And that is it. That's the final step to the plan. They haven't told me what to do to check. So I've done whatever I could to check to see if it was correct, my solution. So what I've done is I've taken both of my equations and I've substituted x equals 0 and I've solved for f of x and g of x. Sorry, f at 0 and g of 0. Like so. As you can tell, the first y-intercept is 8 and the second y-intercept is 14. Then I've subtracted both y-intercepts to see what the distance is apart between them, and 14 minus 8 is equal to 6, so the distance between them is 6 units, which meets the criteria. Now the individual did not tell me how I could check my point of intersection x value to see if it's large enough or not, so I went ahead and just graphed it, and right over here is the graph of both functions. As you can see, the point of intersection is at negative 284 and 32.6. This is actually a very large x value. Arguably, some people may think that it's actually a very small value, but that's arguable. And for me, I believe that this would be sufficient for the plan. So negative 24 would be a good x value for the point of intersection, and the plan works. For future reference, the person should edit their plan a little bit more, use a little bit better terminology, and look into the equations they provide the individual to read with. Otherwise, it was a great plan. Nice job.